Let us see how the power will distributed in electrical utilities. So here the power distribution system depends on voltage levels, that is primary distribution and secondary distribution with respect to kilovolts, so which are in 3 phases and 3 wires, so which vary from 11 kilovolts to 33 kilovolts, the maximum. And in case of secondary distribution, it may vary with 11 kilovolts, 415 volts, 220 volts, and it in with the 3 phase and 4 wires. So there will be a consumer, intermediate consumers are available here, and distributors are available here. So obviously variable current density is there, and size of the conductor depends upon voltage drop. So in case of primary distribution, we can majorly observe the voltage reduced from 33 kilovolts to 11 kilovolts with respect to 3 phases, and this 11 kilovolts lines run along important roadsides of the city, and big consumers, they have the demand over 50 kilowatts, are generally supplied power at 11 kilovolts for further handling with their own substations. And in case of secondary distribution, the electric power from the primary distribution is delivered to distribution substations, and these substations located near consumer localities. And here the step down the voltage or to around 400 volts with the 3 phase. The voltage between any 2 phases is 400 volts, and between any phase and the neutral is 230 volts. So this is what the domestic purpose, and for little bit higher consumer localities. And the single phase residential lightning load is connected between any one phase and neutral, whereas 3 phase 400 volts motor load is connected across 3 phase lines directly. And the secondary distribution system consists of feeders, distributors, and service mains. So we can compare up the current with direct current and alternate current transmission system. So in case of direct current transmission, we have advantages like it requires 2 conductors, and there is no inductance, capacitance, phase displacement or surge problems. And due to absence of inductance, the voltage drop in DC transmission line is less than AC line, and there is no skin effect. So from the same working voltage, the potential stress on the insulation is less, and a DC line has less corona loss and reduced interface with communication circuits. And high voltage DC transmission is free from dielectric losses, and even there is no stability problems, and synchronizing it can be synchronized the difficulties. And the disadvantages that we can observe majorly, the electric power cannot be generated at high DC voltage, and DC voltage cannot be stepped up for transmission of the power at high voltages, and DC switches and the circuit breakers have their own limitations. And let us see the AC transmission. So nowadays electrical energy is almost exclusively generated, transmitted and distributed in the form of alternate current. So advantages, basically we have power can be generated at high voltages, and maintenance of AC substations is easy and cheaper, and AC voltage can be stepped up or stepped down by using the transformer, and AC with the efficiency, and this permits to transmit power at high voltage, and it can be distributable in a safe potential way. And disadvantages like AC line requires more copper than the DC line, and construction of AC transmission line is little bit more complicated than DC transmission, and because of skin effect in AC system, the effective resistance of the line will be increased, and AC line has capacitance, therefore it is there is a continuous loss of power due to charging current, and even when the line is open.